Hello and welcome to today's video. So in the previous video, the X-Tech Quad Power Supply Upgrade Part 5, I mentioned that my microcontroller doesn't have enough drive strength to turn on the opto-isolator fully, and thus I can't drive my relay because I'm limited to 10 milliamps on syncing and sourcing current from one pin on my microcontroller. Well, I got this comment here from Randy Carter 2001, and I'm not picking on him. It's a good comment. I like these kind of comments. But it ended up generating a lot of emails, so I wanted to actually show that this does work. This is in fact what happens. So Randy wrote, "I didn't think it would work when I first saw the drive circuit. The first thing I noticed, you were using the optocoupler in its lowest gain linear configuration. The emitter should be grounded in the collector used for output in digital applications." And then my response was, "Is that true for an opto-isolator?" That should actually be a question. "The base current only depends on the amount of photons hitting it, the photoelectric effect. I was under the assumption that the opto-isolator can be used for syncing or sourcing current, which is why there are no PNP opto-isolators." Winky smiley face. "And it does work perfectly fine if my microcontroller pin could source 20 milliamps to the LED. So I got a bunch of emails. People are saying, "Oh, they're saying, oh yeah, that's totally right," and other people are saying, "Oh no, that's totally wrong." So I've got an experimental setup. Let's just see what happens, right? So I have this wired up. This is the original circuit, which is on my board, and then so this is the sourcing, and this is the syncing circuit, and I'm going to show operation of one versus the other. And just to help, this is the schematic here. So this is the circuit that we've got wired up right now. I have two 100 ohm resistors. These go to two I/O lines on my microcontroller. So I can turn on one I/O line, then the other. So we'll get 10 milliamps with one on and 20 milliamps with two on. And then the optocouplers is connected to the relay, just like this. So we're sourcing current. So you got 21 volts going through there, and that should get that should turn that guy on. And then the other circuit is the opposite. So we've got the two 100 ohm resistors, same two inputs or outputs from the microcontroller, so 10 milliamps each. And then the others, we've got it to where we're syncing current. So we've got the relays always connected to 21 volts, and the transistor in the optocoupler is connecting to the ground. So this is the circuit that Randy says will work, and this is the circuit I say will work, or this is the one that I built, and we're going to go ahead and see what happens. So trust me, this is all wired up. I've just tapped off of a couple of the I/O lines. They come over here, and then it looks like a lot of stuff here, but we've got these two wires. They're going off to the cable that runs the relay, and I have a lamp attached. I got it set to 12 volts. This draws more than 5 amps, so it'll actually current limit at 5 amps. And I've got the voltmeter. If we follow its leads to the yellow and black or yellow and green are just across the diode. So we're measuring the voltage that is going to the relay, and we'll do that in both cases. So without further ado, this is the circuit as it's built in my design. And I've got it set up to these I/O lines, so I'm going to turn on one I/O line, and you'll see the voltage goes up to 4.7, and you see the voltage starts creeping up a little bit, and that's because the poor opto-isolator is not fully on, and it's actually getting a little bit warm. And if I flip, so I'm only putting out 4.8 volts to the relay, which is not enough to turn it on. If I turn on the second I/O line, so now we're going to get, so this is 10 milliamps, we're going to go to 20 milliamps, and if I click that, you heard the relay click, and the light comes on, and we're now putting out 17.5 volts. And then if I go ahead and I can turn off either the first I/O line or the second I/O line, it doesn't matter, I click that again, and we're down to 4.7 volts again, and you can see that the light stays on, because that 4.7 volts is enough to hold in the relay. So if I go ahead and click the other one off, now it shuts down. So we can do the same thing. We'll do the other I/O line, 4.7 volts, relay, nothing happens. We click it again, we click the other line. Now we got 20 milliamps going into the optocoupler diode, or the LED, and that's enough to turn the system on. So it does work perfectly fine as built, but we'll go ahead, I'm going to pause the video, I'm going to transfer everything over to the other circuit, and we'll try the other circuit and see if we get any different results. So go ahead and flip it off again. See, we're down to 4.7 volts. Now it's off. So I'm going to pause it, and we're going to swap everything over. Ready, set, pause. Okay, and we're back. So as you can see, I've moved everything from one circuit to the other. Same exact setup. Nothing else has changed other than we're going to the other circuit. This one was sourcing current, and this will now sync current. So just as a reminder, we're now set up as this circuit right here. So we're now syncing current to ground. And we'll do the exact same thing. I'm going to turn on one I/O line. And you see we still get the exact same voltage, 4.7-ish volts. And the light didn't turn on. We go ahead and turn the other I/O line on. Now we're putting 10 milliamps into it. We're going to put 20 milliamps in. Boom. Light comes on. 17.5 volts. So the circuits are identical. You can actually use an opto-isolator in either configuration. It doesn't matter. And the reason that's true... Ooh, that's nice and bright. It got hot enough that the fan came on. Yeah, this little light actually draws 5 amps, so we are on the current limit. Or more than 5 amps at 12 volts. Here, let me go ahead and I'll just go and flip this off here. So again, I turned off one I/O line. If I turn that line back on, see, it's just going to be the same. Then we turn the other line off, and the output shuts off. So if we look, what's going on in either case, we're essentially sending photons over to the base. And those photons knock electrons off of some silicon atoms, and those electrons combine with holes in the NPN material, so they combine with the P material, and that causes current to start flowing. So these two grounds don't have to be the same. They can be completely isolated, and it'll still work. Now, technically, you do get it's not infinitesimal, slightly more current with this configuration. So Randy is correct. But it's very small. So say I've got a microamp, so I'm sending photons across here, and the transfer ratio is really poor. So we're getting maybe a microamp of current striking the base. That current has to go somewhere, and it does go to ground. And if it's connected to ground, you get 1 microamp. If you are sending current through here, you get 1 microamp, and it just develops a slight voltage across here. If this is a 600 ohm coil, it's going to be 0.6 millivolts. So it's not very big at all. So you're just getting a little tiny extra voltage in this configuration versus the other. But the beta, the gain of the transistor in either of these cases is going to be well within that margin. If they're even, unless they're perfectly matched transistors, you won't be able to measure the difference between the two. But it does work. You can actually use an optocoupler for syncing and sourcing. It doesn't, or sourcing and syncing, it doesn't matter. And the only reason you would prefer one over the other is when this circuit is off, the relay is always connected to ground. And when this circuit is off, the relay is always connected to 24 volts. So it's always better to do it this way, to where your relay is connected to ground and it's always at a ground potential. If this was a normal transistor, not an optocoupler, you would want a P channel here, so that you just have to pull the base low or get some current flowing through the base, and then that will turn on the relay with the P channel. And in this case, you would need an N channel transistor, and you would apply a little voltage, and that'll cause a current to flow into the base, and it'll conduct from the collector to the emitter. So it's different, it's odd when you're dealing with optocouplers because it operates purely on the photoelectric effect. But anyways, this is supposed to be a quick video, and it's already 10 minutes long, so Hope that was educational. Thanks for watching. Bye.